Hi everyone, Miss Donnan here. Today we are going to have a look at the first section of this new topic. The new topic is esters, fats and oils, and we are going to spend today having a look at lesson 1, which is making esters. So our learning intention is to carry out an experiment safely to investigate the process by which esters are made in the lab. Of course, you are going to be doing this experiment in class, in school, but we're just going to talk through the procedure and also go through some of the properties of esters, how to identify them, how to draw them, etc. So our success criteria, what we want to be able to do by the end of this is identify esters, so look at a molecule and you can tell that it's an ester, name them from their structures, and obviously describe the procedure for making esters as well. As always, you have a little starter question just to get you started. Which is true of a compound with the following formula: A, B, C, or D? See if you can answer that. I have a feeling that the answer is going to come up when I press next. So pause the video, have a wee go, and then unpause to see the answer. And it is D. It can be oxidized to a ketone because the OH is in the middle of the molecule. So, esters. Now, the blanks in your notes are in bold on the PowerPoint, so make sure that you are filling these in as you go along. So when an alcohol and a carboxylic acid react, this is going to produce an ester and water. This type of reaction, now the reaction type is a condensation reaction. And this is where two molecules join together to form one large molecule and you have a small molecule eliminated. Now in esterification, that's the process of making an ester, the molecule is water. And when we look at putting these two molecules together, I'll show you how the water molecule comes off. A condensation reaction is very important. You need to know the definition for that. And you need to know that esterification is a type of condensation reaction. So, esters are a new family. They are a homologous series, and these can be identified by the carboxylate functional group, which is just shown in your notes and in this diagram here. It is COO. That's also known as an ester link. So when you see it in the middle of a molecule, of an ester molecule, then that means that is the ester link. You are often asked to circle these in exam papers, past paper questions and things. So I'll show you how to do that as well. So here is our equation for esters. We have a carboxylic acid plus an alcohol in the presence of concentrated sulfuric acid, which acts as a catalyst. We then get out our ester, which is the product we want, and our little byproduct is a water molecule. So example 1, we have ethanoic acid plus ethanol gives the ester ethyl ethanoate and water. Here is what the equation looks like. We have our ethanoic acid. We know how to draw ethanoic acid already. So we have our two carbons and our carboxyl functional group. Ethanol is our alcohol, so we have two carbons here with our hydroxyl functional group. And what happens is we take the OH from the acid and the H from the alcohol, put those together to make water, and then just simply join the other two molecules together. So where this OH, this one here, comes off, this O with your two carbons comes on. That forms this structure here, which is our ester. In this case, it's ethyl ethanoate, more on naming in a wee minute. But as you can see in the middle, we have here this carboxylate functional group, which is called the ester link. And that contains the C, double bond O, and the other O. Don't include anything else, just those three atoms in your ester link. And of course, we get our water being produced as well. So that is the first example to copy down into your notebook. The second example is propanoic acid plus methanol gives us methyl propanoate and water. Now, in the last example, it was ethanoic acid and ethanol, so it didn't really matter which way round each of the words were. This case, it actually does. Now you'll see that when you name the ester, it is the alcohol part that comes first, and then the acid part is the O8 part at the end. So let me just show you what this looks like then. We have our propanoic acid, so 3 carbons and the carboxyl functional group. Easy peasy, we know how to draw carboxylic acids. Again, with the alcohol as well, we have methanol, so 1 carbon and our hydroxyl functional group here. We are then going to take the OH from the acid, the H from the alcohol, and join the molecule up. So we have our propanoic acid part of the ester here, and then it gets joined onto the O part of the alcohol here. And we also have our little water byproduct as well. So here is what is coming away to make the water, the OH from the acid and the H from the alcohol, and we end up with our ester on the other side. Again, this is one for you to copy into your notebook as an example. So, making esters then. When you are back in class, you will carry out this procedure in the lab. This diagram looks very complicated, but it's not. The procedure is pretty straightforward. So esters can be produced in the lab by adding an alcohol to a carboxylic acid in the presence of concentrated sulfuric acid. Now, when you do this in the classroom, you will get to choose whichever alcohol and whichever carboxylic acid you like. Hopefully lots of people will do some different combinations, because what happens is, or what one of the properties of esters are, is that they are very pleasant smelling. If you get a good combo, one of the combos produces a smell very similar, or which is the flavouring in pear drops, so you can make some really, really nice smells. You do need to use concentrated sulfuric acid, so your teacher will help with that, and you'll also be carrying that part out in a fume hood. So what you do is you take a test tube and you add in your carboxylic acid, alcohol, and your catalyst, which is sulfuric acid. You then get a wet paper towel, and this is very important, and wrap it around the top of the test tube with an elastic band. Now you'll see the word condenser here. Now all that means is that it provides a cool space at the top of the test tube, so anything volatile, in other words anything that easily evaporates in this mixture, like alcohol, is not going to escape. It will be cooled back down into a liquid and it will remain in the test tube. So that is what the wet paper towel is for. That's a commonly asked question. You're then going to place this in a water bath. This is in the beaker of hot water. And then add in a loose cotton wool plug as well, just to stop any of the mixture coming out of the test tube. Then what you do is, once the reaction has finished, you add some sodium hydrogen carbonate, which just neutralises any leftover acid, and you mix this several times and end up with 2 different layers, as you can see in this diagram here. You end up with the ester, which kind of looks very oily, and it floats on top of the water. So this tells us that esters are not soluble in water, and they are also less dense than water because they float on the top and don't mix with the water. So what you can then do is do the favourite chemistry waft. Do not sniff this. It will very much hurt your nose and your teacher will not be happy with you. So do the chemistry waft and you will smell some nice smelling esters once you're finished. You do need to be able to draw and label this entire diagram. Also, the SQA can ask you anything about it, so make sure that you are up to scratch with your making esters procedure. Obviously doing it in the classroom as well is going to help you out with that. So we don't need this procedure, but can I just highlight do not sniff. So common questions that you are asked about the making esters procedure. So I've already told you sodium hydrogen carbonate just neutralises any excess acid. It will fizz a wee bit because it produces carbon dioxide gas because it's a carbonate. The wet paper towel acts as a condenser which stops any molecules evaporating. The loose cotton wool plug is used to stop any of the reaction mixture spraying out of the test tube. And lastly, this is a reversible reaction, which means that as the ester is being produced, esters can also hydrolyse back into the products again, which means that 100% of the theoretical yield, which just means the yield that we think we're going to get, might not form. So it's a reversible reaction. Okay, naming esters then. So how do we name the esters? We saw before the alcohol part comes first, and then the second part of the name comes from the acid. So I've tried to colour code this a wee bit. Hopefully that is helpful. So when we have methanoic acid and ethanol, we're going to have ethyl. So you take the all off and they end up with ethyl for the alcohol. And then the acid becomes methanoate. So the first ester name is going to be ethyl methanoate. The second one then, we have propanol and ethanoic acid. So this is going to become propyl ethanoate. The last one, we have methanol and butanoic acid. That's going to become methyl butanoate. Again, this is something that you have to copy down into your notebook so that you have these for future. Naming and drawing esters is just something, again, like any new family, once you practice it lots and lots, you will end up becoming an expert at naming and drawing esters, just like all of the other families. So, drawing esters then, the C double bond O part comes from the acid part of the ester. So this is what the diagram shows here. So this is ethyl butanoate, because we have 2 alcohol carbons and 4 acid carbons. So ethyl butanoate is what this diagram is of. Again, practice makes perfect. The more you practice drawing esters, the better you become. Here are 2 examples. Again, butyl methanoate and ethyl ethanoate. I always draw the acid first and then add the alcohol on at the end. So if I know I have ethyl ethanoate, for example, I will draw my C double bond O with my carbon with 3 hydrogens attached, and then I'll add the O from the alcohol and the other carbons from the alcohol as well. That is just my personal preference. You might not want to do it that way, which is absolutely fine. Okay, let's kind of test what we know so far then. We have 3 wee questions. One is to draw 3 esters, and the other ones are to name some esters. So, as always, have a wee go at these questions in your notes or in your jotters. Pause the video and then we'll go over the answers when you unpause. Okay, here are the answers then. So the first question is, draw the structure for the following esters. The first one is methyl ethanoate. So here is the ethanoate part. Here you've got 2 carbons with the acid group, and then our alcohol is methyl, which is 1 carbon. Number 2 is butyl propanoate. So butyl is our alcohol part, which is here, and propanoate is going to be our acid part with our C double bond O. Lastly, we have propyl methanoate, which is here. Our methanoate part of the acid is here, and our alcohol part is in blue here. So that is 1A, B, and C. Make sure you don't have any floating bonds. Make sure all of your bonds are in the right places to the right atoms. 2. So name the ester produced from the following alcohols and carboxylic acids. 2A is methanol and pentanoic acid. So we end up with methyl, which is the alcohol part, pentanoate, which is the acid part. B is hexanol and methanoic acid, so we have hexyl methanoate. 3, we have diagrams to name from, so you will look at the diagram, look for the alcohol part, which is the part attached to the single O. For A, you have ethyl, and then your acid has 3 carbons, so it's ethyl propanoate and not ethanoate, as I have actually put in this PowerPoint. I'll need to fix that. And B, we have, let's just check this one's right, 4 carbons on the alcohol part, which is butyl, and 2 on the acid part, which is ethanoate. So butyl ethanoate. So number 3A should be ethyl propanoate, not ethanoate. Whoops. Okay, so lesson 1, making esters then, we wanted to be able to identify esters, name them from their structures, and describe the process by which esters are made in the lab. In the next lesson, we will have a look at breaking down esters, because as we said earlier, this is a reversible process, so it goes both ways. Until then, see you next time.